Well, welcome everyone. While our panelists are taking their seats, I'm going to actually invite you all to stand. You just thought you were here to learn about AI from us, but we're going to start by learning where everyone in our audience is. So I'm going to ask you if you consider yourself a beginner. We're defining that as I've just started experimenting. I consider myself a novice. I'm going to invite you to take a seat. Everyone else remain standing. Are you a beginner? You're going to take a seat. Okay, some of you are squatting. I think we're about probably 40% of the room just sat, you think?
It looks like
okay.
So, yeah.
All right, so if you are 201, this means you're knowledgeable, but maybe not quite an expert. So you're using AI regularly and pretty confident navigating the basics. You're gonna sit down. Okay, I would say we had another.
Wow.
Okay, I think we maybe have 5 to 10% of the room still standing. So I'm assuming everyone, if you're still standing, you consider yourselves a 301 level, an expert, or close to. We've got some doubtful faces here, but we'll go ahead and consider you an expert. You can go ahead and sit down. All right, wonderful. So we did this just to give ourselves and our panelists kind of an idea of where our audience is starting, to make sure that we tailor this presentation to what's gonna benefit you most. So it looks like we have, most of us are in the 101, 201, so we're gonna take, yeah, pretty good chunk, pretty good chunk. So I'm gonna run you through some quick awareness stats, and then we're gonna introduce our great panelists here today. But ThinkLab, if you're not familiar with ThinkLab, the company that I founded and run, is the research division of Interior Design Magazine, Metropolis. It's a Sandow brand. And we've been tracking AI adoption. We started measuring this in around 2004. So you can see from the slide behind me, in April of 2024, about 6% of the industry was knowingly using AI. Now, a little bit of a trick question, right? Because we're all using it in ways that we may not intentionally be choosing to. You can see by November of 2024, 33% of the industry was using it, with another 33% saying, not yet, but I expect I will be shortly. July 2025, that number hit almost 60%. You can see that 59%. And today, our most recent poll was beginning of this year. You see that kind of tapering off a little bit. So lots of theories about why that might be, but maybe that helps you feel, especially with some of the more novices in the room, where we are. So what we're here to talk about today is AI. We're gonna go through kind of a 101, just really starting at the basics for that 40% or so that sat down to start where we were. And then we're gonna go into some use cases in 201 and some really advanced views for 301 for anyone who wants to leave a little bit alarmed into progress and where we could go. So with that, I wanna make sure I introduce our panelists. So I wanna start with Brian with Cisco, our sponsor for today. Brian, you wanna introduce yourself?
Absolutely. So good afternoon, everybody. Thank you for taking time out of your busy NeoCon schedule. My name is Brian McCourt, and I'm with the Future Proof Workplace Studio at Cisco. So we are a team of individuals with industry background that either is in design, real estate, or construction. Because at the end of the day, if you think about it, IT and real estate aren't really like two siblings that hang out together at Thanksgiving, right? So for myself, I've been at Cisco for 5 years, but prior to that, I was with Steelcase for more than 20 years. So the first thing I'll say is like, if I can learn technology, you all can learn technology from that perspective, right? And so I just want to kind of give you a bit of an overview, because I think if I look at the collection we have with NVIDIA and Microsoft, I think Cisco's not one of those well-known brands. So I have a lot of people approaching us at the booth saying, from industry, hey, it's great you're here, but why are you here? So just because you may be familiar with the other brands, just a couple different things. And the first example I'll give is that we were building out our Atlanta office. And the head of our Atlanta office, the design team, got a call from the city. And the city said, hey, Ray, just a question for you. How many kitchens are you going to have? And Ray's like, well, it's kind of an odd question. Why do you ask? They're like, well, how many kitchens are you going to have? And Ray said, well, you know, we do a lot of customer entertaining. We're going to have a kitchen, a professional kitchen. And the gentleman says, huh, but aren't you Cisco, the food prep company? And I share that, that is a true story. And I share that anecdotally because you know the name Cisco, but you don't really probably have an understanding for what we do. And admittedly, this is not going to be a Cisco speech, I can share with you. But when I joined Cisco, it was really unclear. So just a couple little give you some guidance on it. So today it's estimated that 80% of all public internet traffic goes over some type of Cisco equipment, right? So in the 1990s and 2000, we built, my word, the digital plumbing for the internet, and we're going to continue to do that. So we are a connectivity company. We call it the fourth utility. In 2001, we connected the telephone. 08, 09, we created telepresence rooms. Today, we're connecting people, places, and things, as you saw in the video. So when you think of Cisco, just think of us as connectivity. And the second part I'll share with you when you think of us as a data company, right? So Your IT and your AV system are the largest sensor you have going in your building. When we work with global real estate on their digital transformation journey, they have no idea what IT can provide. I only share that because we see the most successful projects happening when IT, real estate, and HR are coming together to determine kind of how do we transform the way people work in those types of things. Make sense? Alfonso, you want to?
Great. Yes, thanks, Brian. Hello, everybody. Thanks for being here. First of all, my name is Alfonso Oliva. At NVIDIA, I lead developer relations for the AEC industry, architecture, engineering, construction. What that means is that daily I talk with ISVs. Most of the applications that you guys use, think about Autodesk, think about Trimble, Nemcheck, Bentley, and so forth. And also startups, of course. You might have seen how many startups popped up like popcorns in the last couple of years, and companies, so individual companies. And I basically advise them on their AI journey. So I advise them the best way to implement tools and how to use them. I am a designer turned technologist, like on the way. In fact, my journey goes back to, I'm based in New York now, but my journey goes back to Italy when I started my studies. Don't get tricked by my New York accent. I'm actually Italian. So my journey started back then, and then I landed in New York, and I started working as a structural engineer. Soon enough, I learned something that I'm going to share you later. I learned that technology is a vital part of our workflows, and it can really help us get closer to our purpose. I'll show you a practical example about that. And then fast forwarding a few years, I got very passionate about technology. I had my own company before joining NVIDIA, and I pursued a PhD in machine learning and AI, which brought me to what I'm doing today. So I feel like I'm in the perfect environment, the perfect conference at the intersection of design and technology. And I want to thank once again, Brian, for the invitation. And I'll pass it on to Nandan.
Awesome, awesome. Thank you, everyone, for having me, and thanks for being here. My name is Nandan Oza. I'm from Microsoft. I'm responsible for our partner ecosystem, focusing on industry software solutions. And I have a lot of smart people that work on my team, and they actually work closely with some of the partners and some of the companies and bring AI into real world in terms of products and workflows. So I've been with Microsoft for about 5 years. Prior to Microsoft, I was also working at Cisco, and I had the exact same experience. When you say Cisco, they're like, oh, the potato farmers. I'm like, no, right? So we've come a long way. But here I'm super excited to talk about AI today, not just where is it today, but also where it's headed. So thanks again for having me.
Wonderful. So I believe there's a QR code where you can ask questions. We are going to save your questions for the end because we're going to try and get through a lot of this. But let's start with kind of a 101. So we're going to start super, super basic. So Brian, maybe you can start us off in layman's terms. What is AI? Where do we need to start?
Yep. So as I kind of mentioned, our role is to kind of be that Rosetta Stone, right? To kind of be the translator, if you will. So what we're going to use is there's a gentleman by the name of Alexander Wang. He is now the Chief AI Officer for Meta. Prior to that, he started his own company called Scale AI. And an interesting thing about him is he left MIT, as one does, and started his own company. He's actually the youngest billionaire. Not that it's relevant, but what I really appreciate about him, he's very relatable. And then what I find in the industry, there's like a lot of good conversations about AI with manufacturers and consultants. And everybody's talking about AI from a workflow and work process standpoint, but nobody's talking about AI in the as-built environment, the physical environment. So our goal today is to really make this kind of a relatable situation for you all. My experience has been being on the Cisco side, and I'll share this, is that when I look at other as-built environments, so Alfonso and I were talking about this, manufacturing uses a lot more technology than the commercial office environment. Distribution uses a lot more. Alfonso was mentioning that from an agriculture standpoint, AEC is below agriculture from a technology adoption standpoint. So I think that part of the issue in our industry is we just need some foundational information. That's how I started my journey. So this is meant to give you kind of a baseline of it. So when you think of AI as compute plus data plus a language model. So for this, Alfonso's handling compute with NVIDIA. I'm handling data. And Nandan's handling it from a language standpoint, right? You really, starting with those three basic core elements, and this is how this day is structured, will kind of help us on the journey from that perspective. Now, the big thing is, I mentioned like everybody's using the term AI. There's different use cases for it. So before we talk about the evolution, let's talk about an internet search, right? An internet search is basically something that's an explicit search. So I'm going to take you all to Paris, right? Get a head count, we'll figure it out. So if I go out and do an internet search, I want 100 tickets for this date. All I'm doing is I'm actually going out to a file cabinet from the airlines and explicitly getting back what that information is. Where we are from an evolution, from an AI perspective, we're now at what's called an inference inflection point. So inference is very different than explicit. So inference is that you give context, you read something, you do some research, and you give a recommendation. So I'm going to give you a simple little personal example, right? So I've always been big into health, so here's kind of a life hack if you're into it. So if you've ever done like DNA testing, I know like everybody's concerned about DNA testing, but if you've done 23andMe, XY, or something like that, you can get your raw data and throw it into an organization called geneticgenie.org. It'll actually tell you what your genetic mutations are. So genes are just code, quite honestly. They turn on and off. So if you know your genetic mutations, save that as a file, because we're going to go into chat as this example. Get all your current blood tests from your doctor, save it as a file. And then what you want to do is, I talked about inferences about context. The thing that AI does not have, it does not have context. This is the human aspect that cannot be replaced, right? So I'm going to say, for this situation, I'm going to say, be Dr. Mark Hyman. He is somebody at the Cleveland Clinic that does functional medicine. Read my genetic mutations, my reports, and I'm feeling tired. Give me some recommendations. It came back and told me what basic vitamin supplements I needed, and I have what's called a methylation issue, which 60% of you have. It dramatically changed it. I only share that as a simple example is that's very different than a Google search. That's really kind of from an inferencing standpoint, right? Make sense? What agentic does, and we use the example of like Claude Cowork, it does those 4 models, but actually takes action for you. So my fiance, she's a fractional CEO for the trades business. Like, she's not technical at all, right? But if you guys are familiar with Claude, it's like an Anthropic product. There's a product called Cowork. You can set up a personal assistant. You give it context. I'm a business owner. These are my clients. Here's my information. And she set up an agent that's her personal assistant. So every morning, it goes out and reads her emails, her Slack channels, looks at company financials, and it gives her a daily briefing. And it asks her, would you like me to schedule meetings with your customers? It's simply doing, that's what we mean from an agentic standpoint. And today, we're really at the inflection point from agentic, and this is going to be a big part of the conversation. We talk about team of agents. I was going to give a different example, but you want to talk about from a team of agents standpoint?
Yeah, definitely. Perfect introduction from Claude. So Brian gave you an example of agentic AI, right? Agentic AI is the second step after basically using a single LLM within a particular workflow, right? Which is what we've been doing since the last couple of years. I'm pretty sure most of you here are using at least ChatGPT. Some of you are using Claude or many other tools. Now, imagine that within your specific workflow. We know that within our workflow, with whatever we design, we are using from 3 tools, if we are lucky, but that's unrealistic, up to probably 15 different tools, right? Because every single tool does something very well. Now, how do you coordinate all these different tools together today? It's very painful, right? It's one of the most painful processes out there because they don't talk to each other and everything. Teams of agents can actually help you do that. You can create agents which are experts, as Brian was mentioning, in one specific task. For instance, an agent that is specific for Blender, or an agent that is specific for SketchUp, and so forth. These agents are so smart, they understand everything. You can do your work, you can focus on your design and your modeling, but once you have to go from software A to software B, you can delegate that to the agents without having to start exporting in many different files and go back and forth and so forth. I'll talk a little bit more about this later in my session. I'll focus it actually on agents, and I'll give you the distinction between task and purpose.
Thank you. And the last one we'll talk about is physical AI. And in physical AI, a driverless car is basically a square physical robot, right? Like, it's unclear what timing will be like, but it'll be doing physical types of activities. I think we all have an understanding of that. So I think it's really important we talk about AI. Let's not use it like Xerox or Kleenex. Let's talk specifically about the use case. And our goal, again, is not to talk about part of the work process, but what does it mean for the as-built environment, if that makes sense. Alfonso?
Yes. OK, so we need to all step back, and I need to bring you back on time. And I'm pretty sure nobody's going to mind to go back to the 90s. I want to go back to the 90s.
80s. I would do the 80s.
So bad? Yes, 80s even better. So NVIDIA was founded in 1993. And the reason why I'm mentioning this is not to give you a whole speech about NVIDIA, but there was a fundamental shift, basically, that happened back then, which we're probably all aware of, right? So we were very much used to CPU. Okay, so something that is optimized for serial tasks. And back then, NVIDIA introduced a GPU, right? Something that is very good at parallel tasks. The way you can think about this is a CPU being, for instance, in a restaurant kitchen, having a series of chefs that are very, very good at one specific dish, right? Every chef is specific to one specific plate, which you will serve outside. A GPU, instead, it's a series of cooks which work in parallel in the most possible efficient way to create that dish. So you get basically more speed and more quality, right? So that was a fundamental shift. And back then, me, as probably some of you, were chasing GPUs from NVIDIA for gaming, right? NVIDIA was, in fact, born in the gaming industry. Now, fast forwarding a few years, what happened is that NVIDIA released CUDA. CUDA, basically, it's a programming language that lets you access the GPU. And all the ISVs out there, you see some of them here, right? Bentley, Autodesk, and Nemcheck, Matterport, and so forth. They were like, wait a second. This means that I can get my application, which my designer loves, and I can make it run faster on GPUs. And that's basically the next fundamental shift. And it's the first access point for you for the speed of GPU. So this is really step 0 and the foundations of compute. And moving forward in the presentation, we'll see how we build on this and we agentically basically start streamlining our workflow to make us more efficient, but more importantly, to make us focus more on the design rather than the tedious task or the repetitive tasks that, of course, it's part of every single design.
Mm-hmm. Thank you. So compute is the physical layer. Think of data as the fuel, right? And I think for me, kind of the best way to talk about this is, I think this is probably one of the most under-talked about topics, quite honestly. So, NVIDIA is the leader when it comes to GPUs and compute from that perspective. Microsoft's the leader for language models and enterprise level. Data's the part, that is really your secret sauce. So to give you a bit of context, all the large language models, so Claude, Anthropic, to build themselves, they use all the available public information about a year ago. So really the next advancement from a data perspective is private data, that's your own data. So think of data has to be thought as a capital asset. It is your secret sauce, and I believe data is a new love language for real estate and design. And I think we get into it, we'll share a bit more about that. So I'm gonna give you just some basic information here, and then I'll tell you what I think is just one thing you should remember for it. So first of all, there's types of data. So there's structured data. So think of structured data like an Excel file, right? I put something into it, and it's Excel. It's very easy for the language model to read. There's unstructured data. Unstructured data is PDFs, those types of things. The largest, I just heard this, the largest unstructured data source for language models to learn from is actually Reddit. Because you think about Reddit, like we communicate like humans in it, and it helps the language models understand how we want to interact and talk, and it's just a very large source. And then there's synthetic data. The reason this is all important is because MIT did a study last year, and they called it like the AI Business Impact Report, and they used the term data chaos, right? And for them, data chaos equals data that's unstructured or ungoverned. The issue is when you have unstructured and ungoverned data, the results out of AI are misrepresentations. So there's a lot of people concerned about, AI is ghosting, bad results. It is, but it goes back to the old cliche, garbage in, garbage out, right? So this is where we really have to start talking about how we're gonna get a hold of data. JL had a report last year, and they estimate that only 7% of all organizations have excellent data that's structured, right? I can tell you, even from a Cisco perspective, we're working on it. So The next thing is, so that's kind of the types of data. There's this big difference between open versus closed. So open means it's available to everybody. Closed means I don't have access to it. So at my employer, I cannot access other people's HR information or payroll. That's considered closed. Proprietary means actually ownership. So who owns the data? And we see a lot of organizations when they're out buying different IoT sensors, like when you're signing up for these subscriptions, who actually owns your data? You see this a lot in various building management systems. They actually own the data, right? Where you want to get to, and this is really the most important part of my slide, is you want everything to be what's called open API. So API means application programming interface. It's basically you have two software programs, and in the middle is this decoder ring that allows them to talk to. So I'll talk about make ready, but the big thing to important is when you're specifying projects, it's really important in your general requirements and your Division 1 and your Division 25, you need to specify open API. Otherwise, when you flow down through the design and procurement process, suppliers or vendors, people who provide building materials, they're going to give you the cheapest solution and probably get you locked in to something that's proprietary. And we get into the 2-1 conversation, that's going to greatly limit you.
So I have a question from our audience. I want to understand what types of data is this? Is this like workplace occupancy? Like give us an example of what these different types of data would be and what they're trying to protect.
So they're trying to protect the data, so you have to buy a subscription.
Okay. But what type of data is that? Is that like
it's
how many people are
energy,
using?
air quality,
Energy, air quality.
space behavior,
Okay.
everything. But think of data not only, we'll get into the next section, it's not only real estate, but there's HR data, right? This is all needs to come together, but it's any kind of information coming through your space.
Got it.
Everything imaginable. Because you don't really want to, good question, you don't want to limit what it does, but it's got all this, it's called telemetry data. You want to make sure you can access it, because you're paying for it, you're opening it. Like, what's going to make your language models unique is the data that you run is the most important point. Does that make sense?
Yep.
And then make ready, this is just a way of like, just if you have a data scientist or IT, just make sure you work with them on how you're going to collect it. Collecting means data gets collected what's called at the edge. So every endpoint, your HVAC, your cameras, your sensors, your Wi-Fi, everything gets collected at the edge. You normalize it, which means you can make it meaningful. You index it, think of like the Dewey Decimal System. Remember libraries were a thing at one time? I know they still are. Vectorization means how does it relate to one thing? And then security is a huge, huge issue. I'm not going to talk about it. It's way above my pay grade. I have a good team that handles that. But the main takeaway is make sure that when you're designing or procuring things, everything is open API, and we'll share with you more about after that.
Awesome, thank you. So Brian talked about data as a fuel, right? And you heard Alfonso talked about compute as engine. The part that's missing is the reasoning, right? You're collecting all the different data points, right? You know, different telemetry at the end user data point. You look at the building floor plans, HVAC, right? Videos, all those data. Can you collect it and turn that into something insightful, right? That's why I like to think of LLM as reasoning engines, right? In the old days, you had data across different systems. Now with AI, you can reason across all different systems simultaneously, right? Think about AI. AI now is ubiquitous, right? You look at every day what you do, you are interacting with AI in some form or fashion, right? Whether you are scrolling through Netflix, looking to kind of binge watching, or adding something to your Amazon cart that you don't even need, right? Or just interacting with the chatbot like ChatGPT or Claude, right? As we look at the future is not just text, right? The future is multimodal. And what that is, it's text, video, voice, floor plans, building material, HVAC, all that you want to combine it and you want to turn that into something more insightful. At Microsoft, we have a term called frontier firm. These are the companies that are doing it right? They are well beyond just a proof of concept or any kind of pilot initiative. They have truly AI native operationalized their companies, right? If you ask me, the LLM alone is not the value prop. The value here is combining domain expertise like all of you possess, industrial data, and AI reasoning together, right? That's where the value is.
And if I can ask you a follow-up question there too, just think about, you talked about that Netflix, which is something we can all relate to. As you relate it to the work that all of these folks do kind of in the architecture, design, AEC industry, how might something like that show up with some of your data and metrics around physical space?
Yeah, absolutely. So we have a slide for that. So I don't want to
okay, we can wait if we need
steal
to.
anyone's thunder, but I'll talk about it. So we have some of the partners, they have actually the frontier firm that I talked about. So we have specific examples on what they have done, right? That's your Hexagon of the world, Trimble, ANSYS, right? So I'll talk about that, the use cases in just the next slide, if that's okay. Yeah.
Perfect. So let's go into some use cases, because I think that will really help this kind of come to life. We've covered the basics. So for the 40% of the room that were brand new to this, hopefully that makes a little more sense with the structure of how we're looking at this. But Brian, let's get into some basic use cases and how maybe some of these frontier firms or other companies are using them.
For sure. And we're going to go through these quickly because we have a lot of good other stuff. So the first use case is we talked about physical layer, data, and language model. So from physical layer, a lot of video cameras actually can do people counting. So it's not doing facial recognition. It's basically saying there's a triangle that equals one person, right? So it's capturing it at the edge. You take that data through the information, and then you can run it through a language model to actually impact the HVAC system, right? So you could use occupancy as a proxy today, assuming you have access to the BMS or supplemental, where we talked about proprietary versus open, to actually change the conditions of the room. So using it as a way for better experience, but also from a well perspective is one example. Same thing kind of flowing is you can do people counting, run it through a language model like Copilot to understand scheduling and location, and you can report data back on how people are actually using the room. And I just share this because, I think historically it's changed over the last couple of years, but design's very much been this balance between art and science. Probably a lot more art, but you now have the ability to actually have science to make better programming decisions on actual utilization. Does that make sense? So these are current use cases. The limitation is kind of how it's designed right now, but all these are available today.
Awesome. Okay, so let's go into 301, because I think a lot of people are excited to see maybe some of these further out use cases. Brian, do you want to start us off?
Sure. Ooh, with Alfonso.
All right.
Yes, so as promised at the beginning of the presentation, I wanted to show you an example of agentic AI, right? And how it can help you within your workflow. That's in fact one of the questions that I get every time I'm at a conference is, how can I use AI today to basically make myself more efficient, right? And this is exactly the answer. So here on my right, it's actually me 20 years ago. Right? When I started working as an intern in New York, I was working on designing skyscrapers. The first thing that I noticed back then is that I had to become an expert at many different software, which I loved because I love all the different applications out there and I'm a very 3D driven person. But then with that, it came the pain point. It's, wait a second, this application right here speaks a certain language, and this application another language, that one another language, and they really do not understand each other. So I will basically build my beautiful workflow in all these different applications, and then I will stay over time and, had to figure out all the exports, all the different files, and all of that. That actually brought me, and that's the real use case, brought me to switch in technology within the same field. So I started learning how to code. And the reason why I'm telling you all of this is because I started automating that part of the process, so the painful part, through the APIs that Brian basically introduced before. Now, the big switch and the big opportunity with agentic AI is that you can actually have agents that are experts in that. So you do not have to go out there and start, learning, go in the weeds and learning how to program and do all of that. And you can basically start streamlining your workflow and go basically to this and have different agents that can help you, and become more efficient and make you focus more on design. Next slide. So back then I understood two things. A typical job, whether you are designing something at the product scale, so think about earrings, think about a watch, think about a chair, and scale that up, right, to a building, to a skyscraper, to an arena, or to an entire city. All of these have something in common. You're going to use from 5 to 15 to 20 software within that process. That makes you think about something. In my job, I really have two different things to do. One, it's basically my task, which is part of where all these painful parts are hidden. And then there is my purpose, is what I studied for. It's where my creativity lies and where my excitement lies, right? So most of the time, as I mentioned before, the painful task takes off from the creativity, or at least that's how I felt, but I think you guys can relate. Now, with all that we talked about today, you can bring that together and you can start basically crossing out all those painful tasks. This is how you can do it. I wanted to give a practical application. I'm not going to go too technical on it, but you can see the first layer, which is basically all our different applications. And this can work with any applications that has an API, which is basically 90% of the applications out there. The second layer, which is called MCP, think about the MCP as basically the expert that we were talking about before that knows all the different APIs. So all these applications speak different languages, English, French, Spanish, Farsi, Italian, anything. And then the MCP actually can have a common language for all of them. And then under that, you have your agent. For instance, Brian mentioned Claude before, so I'm going to go back to Claude. And you know the interface with Claude, which is the same one with ChatGPT and everything. So basically, you can start typing and you can be, hey, I worked on this beautiful design in Blender, but my problem now is that I need to bring this in this other application, and I have no idea if it needs to be, which file format needs to be and everything. So the MCP knows all the languages and can make that happen for you. How does that work? That's basically all powered, the brain that basically Nandan was showing before, it's the LLM, right? So you can use an LLM, and as Brian mentioned before, many LLMs out there are trained, like the one that you use with ChatGPT, on the entire internet, right? So they have generic knowledge. They know everything about everything, but they know as much about your 3D model as much as they know about, what kind of plant is that. You probably don't want that. So what you want to start doing you want to start interconnecting this conversation and be, oh, wait a second, now I can get this LLM, but I have the gold in my box, which is my data, so I'm going to fine-tune this LLM, I'm going to throw it in this loop with my Claude, and then all of a sudden, basically, my agents are going to become more specialized, and they're going to know exactly that I want, for this design of my chair, I want these specific curves, which come from my style, my previous design, and everything. So they need to come across perfectly, and they need to respect my design vision. So the bottom line message is, with agents, you can streamline workflows, and you can go back to basically your purpose and your design intent.
Okay, so let's talk about data. So this is the way things are currently designed. It's estimated that 80% of all, I think it was an ASHRAE stat, 80% of all buildings are currently designed like this. So every system you have is actually siloed. So part of what I'm trying to get at is, I think part of it is a design issue. The way that we approach design of building systems is something we can solve for by kind of having this basic information. But we kind of talked about, again, collections at a device level. So you see at the bottom level, everything's collected. It's brought in through its own hardware. Data is collected in its own software program. Remember, we kind of talked about proprietary versus closed. And each building system has its own user interface. This is the way we've done it. And again, part of the challenge is we have to get early in the design process and in the general requirements and other divisions, and require through the design to get where we need to be. So really what we recommend is you have all your normal devices. It's referred to as an independent data layer. So the flow is you have all your devices connecting to one utility, one infrastructure. It goes into what's called an independent data layer, and then you can have some kind of digital twin or something like that. Think of independent data layer in two things. First of all, it's a rule book, which I'll talk about, and it's actually a place to collect data. So the rule book is about, first of all, how am I going to categorize what the data is, right? How do I put it into categories, right? So category would be, I want to know about engineering. Well, Cisco's an engineering firm. You may be an AE firm, so we'd be in the same type of category. The next part of it is, what is the interface? Interface is what the gatekeeper is. So if I have this software program, what is the rules for taking information in, and what is the rules for taking information out? You're gonna be very deliberate, right? Then you've got the data types that we talked about. Then there's an operation standpoint, like how do things flow? Then you get into exceptions and then security. I only share this because it's both kind of going back to your question. Yes, it's about the real estate use cases, but at the end of the day, every enterprise will have an independent layer that has real estate, HR, sustainability, operations, because the models are pretty smart, if we're gonna be honest, and they're gonna come up with insights and recommendations beyond what we would see. So really the big takeaway is, when you go back, is find out if there's somebody in your organization working on an independent data layer. We call it a data fabric, but this is where everybody's gonna be going to, because once we capture it at the edge, it can be used into a language model. Last thing I will say, by not doing this, if you get rid of a device, right? If you have an IoT sensor, you take it off your stack or you take it off your system, where's your data? You left it with your provider. So this allows you to do plug and play at a device level for what's appropriate for your organization. And the data, it's your IP, it's your secret sauce. It's really important that we start capturing it. And last thing I'll say on this is, you really need to start capturing it now, because you can't go back and say, what is history? Because you never captured it. So if you want to run future language models around design or real estate, if you don't have any history, it's like going to your doctor and saying, hey, tell me what's wrong with me. They're like, well, the national average for this blood test is this, so I think you have that. It just doesn't work. It's very personalized. Okay?
Awesome. Thanks, Brian. So this is where things get a little bit interesting, right? Brian mentioned something about digital twin. We've been doing digital twins for years, right? But what we have done so far is all about visualizing your information or your environment. What AI and LLM offers is being able to reason across all those different environments. So historically, the digital twin is very descriptive. It'll tell you exactly what's happening, right? But now we need to take a step forward. We need to do a reasoning over it, because now the LLM is what's sitting between data and decisions. Now, the LLM is sitting in between inside information and action, right? So how do we make that pivot? This is where I'm going to use a couple of examples that, Amanda, you were mentioning earlier, or asking for. So we have 3 partners that I'll kind of mention here, where my team was involved in building this. So the first one is Trimble. Trimble wanted to build a solution which is to kind of focus more on construction planning as well as space utilization. So we have worked with their team in actually bringing AI to the real life scenario. Same goes for ANSYS. ANSYS wanted to build a solution where engineering can run a what-if scenario with AI. So they have done that as well, right? Hexagon, they wanted to look at all different geospatial data and sensor data and build something that they can make decisions for their infrastructure. So all these 3 solutions are available today. They are not vaporware, they are actually real solutions. So this is bringing AI to real life, right? All of that was possible because now we are looking at things a little bit differently. The fundamental shift that has happened now is that we're not looking at digital twin as just informational visualization. It's more like reasoning on top of that. So if you think about it, think of as every individual project will get a digital twin. But now you add a reasoning on top of that, every digital twin will get a digital brain, right? So now you're looking at things a little bit differently. Brian also talked about having siloed information, right? This allows you to break down those silos and consolidate all your data, all your insights, so you can make better decisions and you can act quickly.
Mm-hmm. And can you give us an example of one of those decisions that was made? Did they save money? Did they reduce or increase efficiency in some way?
Yeah, so I think there are plenty of examples, but some of those solutions, I'll just use one, is mainly around space utilization, right? So when we talk about work from home, coming back to the office, all those scenarios, some of the building planner has to be ready for that, right? So what you can ask with the reasoning on top of that, very specific questions. What if I rebuild my floor plans? What if my occupancy goes up 20%? You can sit and do all those calculations manually, or you can let the AI do it for you, right? So like those kind of examples are real life, right? So we can, all that is possible now because we have add reasoning on top of digital twin.
Helpful.
Yeah.
Thank you, thank you. All right, a lot of great information, right? But I want to make sure we leave you with some recommendations, maybe some ways that you can apply this in the work that you do today. So Alfonso, can you, we've got about 10 minutes left, so maybe start to wind us down with some recommendations that they can take home to their work.
Yes, definitely. My biggest recommendation, which has been my basically life belief in terms of career, is go chase that tedious task, that repetitive task that it's draining energy out of your creativity. And tackle that and ask AI to help you with that. And you'll see how the tremendous impact that it's going to have on your design, because all of a sudden you have 2 hours more or 3 hours more to go back to your design, to refine it, and most importantly, in case you want to change it, because there is also a lot of back and forth in every sort of design, product design, again, at many different scale, when it comes back, you are going to have that part of the workflow out of the way. And your creativity is basically just going to flow. Mm-hmm. That's on the basically task versus purpose conversation. So automate that task, go back to the purpose, right? And improve your design solution. And then on the digital twin side, since you guys were mentioning that, start thinking that this is basically starting with AI, with this first part of the conversation, it's really like a step into that, right? So your 3D model so far, it's something that lives during the process, but unfortunately, once it's produced, it kind of dies, right? It sits in a folder, which sometimes we can't even find. We have version final 1, final V2, final V3. It would be nice to have a little context of how many final versions we had in the audience. Mm. But think about this. At the end of the day, getting that product, whichever product it is, and basically giving it a new life during the life cycle of the asset. Whatever there is, again, it could be this chair, right? It could be the building we are living in and so forth. So think about also that. It's a bigger step.
Mm-hmm. Brian, recommendations?
Yeah, I'm going to start with a question.
Ooh,
so my question is, why is it I live in a 21st century world, but my office is a 20th century world? And I share this, I'll say in a loving way. If you look at the different as-built environments, commercial interiors is one of the last ones to adopt technology, right? And so I think we start with education. But why is it easier for me to book an Airbnb for Paris for all of us versus finding a conference room? Mm. Right? And we did a CEU with the help of Amanda and team. By 2030, 74% of employees will be Gen Z and millennials. So if we want people to use space, and in their personal life, they have a lot better of it than the office environment, they're going to be very resistant, right? So I think it's not a technology issue, it's the way that we approach design, quite honestly. We're making technology decisions way too late. It's actually costing customers more money. So we took this approach at our own offices. We reduced our fit-out costs by 8%. Our CapEx, our fit-out costs were done by 8%, below market rate. By connecting all the building systems, we reduced our kilowatts by hour by having like dynamic operations that JLL talked about by 36%. It's not the technology, it's how we're applying it. So my recommendation is work with your IT team, right? Their biggest concern is you want to spend their money and they have to help you. We know you have the OT network, we know that you're funding it. Just start collaborating. The phone was owned by facilities back in 2001. When it came online, it was owned by IT, right? So just so that the big takeaway is you have to start including data early on in your design project as part of programming, including your divisions, or you're going to get the bad design that's going to cost more money, and you're not going to be able to run language models is the net out of it, right? Mm-hmm. So start by learning. I know there's a bit of a concern again, but if I can learn it, I was with details. I did ergonomics and prefab construction. If I can do it, you all can do it as well, is kind of the message.
Wonderful. Nanda.
Awesome. Yeah, I'll give actually 3 recommendations, but I'll be quick. So the first one is start with a business project, right? Now everybody wants to do a lot of AI stuff, right? But start with the business problem and then let the problem decide the tool you want to use, not the other way around. Second is invest in data strategy. Your AI strategy is only as good as your data strategy. And the third, and the most important, do AI, but with the human in the loop, right? And I say that because AI is really good at scale and efficiency, while humans are good at a lot of different things. Like that's your creativity, that's your context, that's your empathy, that's your trust, that's your accountability. So all those things factor in, right? And then I was referring to the frontier firm. That's what I meant, right? AI operated, but human led, right? And I'm a realist, right? So I'll also bring that up that every time there is a major technical shift, there has been some concern around jobs, right? We are all humans. We have all went through that. You look back, there was an industrial revolution. Then there was the computers came along. Then there was the internet. Like if you look back, yes, there were some tasks that were automated, but there were also completely new category of industry and professions were found, right? So think it from that perspective. Essentially, AI is just a tool, right? And like any other tool, it's only as good as the people that are building it and the people that are using it, right? So going back to the original point as well, right? I don't subscribe to the notion that AI is here to replace us. Like I look at AI as someone is gonna for augmentation, not replacement, right? Think it from that perspective. And lastly, I'll say this, that we have the end goal here is not to build the smartest technology. The end goal here is to have better outcome for people, and that includes all of us.
Mm-hmm.
That's well said.
Well said. Well said. Wonderful. Well, we do have just a few minutes. We could take probably 1 or 2 questions, but while I bring up whatever is coming on Slido, I have the first. I will say that we get a lot of questions from the creative industry that kind of is worried that AI might be a negative thing instead of a positive. My favorite is a little meme that says, I want AI to do my laundry and fold my clothes so I can do more creative things, not do the creative things so I can do more laundry, right? So what do you say to any creatives in the room that are really struggling that AI is going to take the pieces of their job that they really love or be a negative to us in some way?
I'll set up and I'll let the architect in the room respond.
Yeah.
So when I was doing a bit of research, we've gone through this before. So during the internet, I was researching it. We thought that the internet was going to get rid of salespeople. That basically customers would go directly to manufacturers, everything would be a reverse auction, and there'd be no need for dealers and salespeople. We also thought that the internet was going to get rid of knowledge workers, right? Because customers could go directly to the source of information. So we know there's changes, but I'm more on the stand with Alfonso and Nandan that it's going to make our lives easier and better to do more that context that the tool will never be able to do. So we've been down this path before. You wanna?
Yeah, I will. For this, I will zoom in into the wave of technologies that Nandan basically was mentioning before, right? Let's back up. So I am older than I look. So when I was studying back in Italy, I was actually drawing by hand, like all my floor plans and even the 3D models and everything, right? And then from that, there was this thing called CAD that came out, and everybody was like, oh my God, that's it. We're done, right? And look at what happened, right? Then from CAD, BIM happened, and everybody was like, oh my God, this is it. And then from that, computational design, I don't know if you guys use tools like Grasshopper and things like that, right? So AI is basically the next tool. Now, one thing in common with all these steps, it's basically the improvement in the design outcome, which is basically what I've been talking about so far. These tools are all aiming to basically streamline these workflows, to automate some of the tasks. Yes, back in the days was going from a pen to something digital. that later on you didn't have to redraw. You didn't have to redraw the entire drawing set. You could just move few things, print it again, right? Then BIM became smarter, and it was like, oh, wait a second, now I can, change my shape and so forth. Computational design, even more intuitive, right? It's like I'm designing this chair. If I change this curve, I don't need to redesign the whole thing. Everything can update on its own, right? And this is basically the next wave, where we are going to get superpowers as designers with our tools, and we can create incredible things. And being honest with you, I cannot wait to see what basically comes out of this in terms of design. I want to see these chairs in this room being completely different basically by next year, thanks to some of the design out of AI and buildings around us and, everything that comes with it.
Well said. Well said. All right, our first, our first audience question. Nandan, I'm thinking this might be a good one for you, but you all can. It's as agentic systems make autonomous decisions in physical spaces, who's accountable when they cause harm? I think a lot of us have had experiences with ChatGPT, having a lot of confidence and not always being accurate. So what is your answer to who's accountable when there is harm?
Yeah, no, thanks a lot for the question. And I think I touched that a little bit on when I was talking about my closing remarks, right? So this is the reason that we always want to keep the human in the loop, right? That's the whole notion of, yes, AI is good at certain things, which is scale and efficiency, but then we also need humans to do the other things, right? And then one of the things that I mentioned was trust accountability piece, right? So that's why you don't want to start letting AI make all the decisions from, doesn't matter what the task is, right? Like you need to have a human intervention because that's the person who's gonna provide the oversight that is needed, whether it's context, whether it's trust, whether it's accountability, you name it, right? Creativity, everything has to come from the human part. So that's why it's the combination. It's the AI operated, yet human-led.
Mm-hmm. Well said, well said.
Can I add on that?
Go ahead, yeah.
It's a little bit, so interesting, because we're in Chicago, right? Pope Leo. Not sure if you know, but I'm a big fan of Anthropic. I think everybody's concerned about the morality of AI. I think it's the elephant in the room. So I think I've always been a fan of what the positions Anthropic has taken. But I don't know if you knew, but last month, Anthropic with the Vatican actually created a joint council. And I forgot the name, it's Italian, but I forgot.
Yeah, I forgot it. Actually, I was thinking about it.
Yeah. But it's basically about, they're creating a committee about what is the moral and ethical use for AI. I only share that because, for understandable reasons, it's on a lot of the right companies' radar to address these types of things. So it's not on deaf ears at all.
So if the Pope's using it, we're good. Right?
Go Chicago.
Pope's on it.
Go Leo.
All right, so our next question is, how is AI impacting the design of hardwire infrastructure in buildings in the next 3 years? They call out specifically residential, office, hospitality. I will say we get this question a lot because we do a lot of research with what we call end user decision makers that are trying to make decisions on hospitals that are going to be built for a number of years. So how is AI impacting the design and hardwire infrastructure in these specific verticals in these next 3 years?
Yeah, I can start, and then of course you guys can jump in, right? But there is something that actually we were talking about it before with Brian, so this is kind of the perfect question, right? I'm gonna go like very deep into one specific example here. Think about MEP, right? MEP is something that it's incredibly complex to design, and it requires, again, like a large number of tools, right? This is a perfect example of augmentation. So we did a very big step going again from 2D to 3D because we can actually start drawing, our MEP system and understand how it fits and all the clashes and all of that. But the way in which, for instance, AI can help you with that, it's through path optimization for MEP. So saving costs for whoever is paying for that, making you a better designer, of course, and also understanding in upstream all the potential problems with, clash detection. Remember, there is always, as Nandan mentioned, there is always a brain behind that, which is thinking about many, many other things. And it can help you and be, hey, you are drawing this conduct, going in from this room to this room, but remember that this other thing is happening, which is going to become a little bit of a problem, more in downstream, right? So that's the augmentation part of the design process that really, really helps you coming up with a better solution from the get-go, which then you can, of course, further optimize. And then, of course, from that, you can push all of these within a digital twin. And to give you guys an example, we were talking with Brian about Omniverse, which is our collection of physical AI libraries, which allow you to basically build physical worlds, right? And within Omniverse, for instance, you can simulate anything, like anything that happens within an MEP system. Why? Because you can actually simulate physics. So imagine basically understanding how the air flows within the different conduits, right? And that also can help you go into deeper analysis within the MEP system and so forth. And again, going into that optimization level that now requires, most of the times goes to the downstream, right? When we start getting pressure that we need to basically deliver everything. So moving the problems in upstream and solving them before, it's, of course, leads to a better design.
So I have a follow-up question, because I know we talked a lot about data and the cleanliness of data. And one thing that shocks me as we do all of our work on the interior design, giants of design, is how few projects actually have that post-occupancy study to see if what the digital twin predicted actually happened. So what's important for our industry to think about as we look at collecting data of what actually is versus models and comparing those? What are we not doing today that maybe we should be considering?
You got to find, what are your project, why is it being funded, attracting and retaining talent? Is it around user experience? Then defining, how are you actually going to measure it as part of the requirement? We never do that. We have goals, but we don't have a measure. That will flow down to your divisions and your systems. So when you move in, the building is set up to actually pull that information. If you don't do the design up front to allow the things we talked about, you'll not be able to measure the outcomes on the back end. It's a design challenge. Recommendation, yeah.
Good. We've got about 1 minute left, so I want to make sure if you've got anything else you want to
No, I just want to thank, so first of all, thank you everybody for your help again. The intent was just to kind of give a baseline of information. I think there's, I come from this industry. It's so good to be back. It's like, it's hard to get out of your blood. We're designers at heart, right? There's a tremendous opportunity to provide better experiences for employees and for our customers by making technology early on. So first I want to thank Nandan. Thank you for that. Thank you. In technology, we rely on partners. So just if you're working on something, you don't have to be the smartest person in the room. You just need to know who you need to reach out to. So Nandan, thank you for that. Alfonso, thank you from that. So just a little bit of word from Alfonso. After this presentation, he's on paternity leave for 3 months. There's a little one. He's going back to Italy.
Yeah.
So thank you.
Thank you for that.
Thank you.
Thank you, Amanda, as always. And I know you've got some exciting news.
I do. I have a couple of pieces of exciting news. One is if you'd like to join in with ThinkLab Research, we are running an AI study, if you want to click us one forward here. So all of you would qualify for this study, and we share the information with anyone who takes it. And the final piece is I actually just published a book. So it's called Work for What's Next. There is AI influence in it, really looking at Gen Z. And newsflash, Gen Z is not the most excited about AI. So lots of information there. We're going to be in the Zinc room just after this if anybody wants to get a book. But we'll invite you to scan this QR code, take the survey, come get a book if you like. And I know you guys have a space here. You should invite them to your space as well.
Absolutely. We're on the first floor. Please come check it out. It's just to make you aware of what's available. Again, technology, you have it at home, you can have it in the office.
Wonderful. Thank you all for joining us today. We appreciate it.
Thank you.